And 19, read the paragraph. The car goes a distance of 1,000 meters from the start line. It hits that line going this initial speed, and it takes this amount of time to get there. And the question is, what's the acceleration? So we need a formula with d, vi, t, and a in it. Go to your formula list, and here's one that works. Now this gets a little tricky, and I did it wrong, I think, 3 times. So let's all concentrate, huh? We put in the distance, we put in the initial velocity, and we multiply it by the time. And then the second part there is 1/2 times, and here's the part that I mess up, is 14 seconds squared. Now, the first time I didn't square the 14, and the second time I didn't say times 1/2. So let's put it all together and do it all correctly. The s gets squared because all of this is squared, and then the 14 gets taken to the second power, and then that gets multiplied by 1/2. If you do that right, then you end up with 98 seconds squared times a. So let's get a by itself. Let's start pushing stuff across the equal sign in a correct manner. I can subtract this over and get new meters. And then we do the opposite of whatever the unknown is attached to. So let's divide. And nothing cancels out in the units. And this is basically 10 times greater than that. And you actually get 10.0 rounded off. And that's correct. It actually rounds to 10.0 even if you put it in the calculator. And the unit is meters per second squared, or remember, distance over time squared, and that is the correct units for A. On 20, it's pretty simple. I left it in just to give people almost like a free layup here. That's a distance, that's a time, and we want your average velocity. So there's our simple formula. Put in distance, time, and divide. Nothing cancels out in the units. You should have distance per time for a velocity. Okay, this one's got another trick to it, so I did it wrong at least twice. So again, let's concentrate. Now, it tells you 2 things about the car. It accelerated from this speed to this speed, or it accelerated from this speed to this speed, but they're both 5 miles an hour different in 1 second. In the first second and then the next second. So they're both the same acceleration, so it doesn't really matter which one you pick. I picked this one. Honestly, it doesn't matter. I labeled this VI, the starting speed for the time frame I want to talk about, which is 1 second, so that's t. And this is VF. It reaches this speed in that second, and we're looking for A in meters per second. So here's VI, VF. Here's VI, here's unknown, and the trick here is it's very tempting to put in 1 second as time. That is not going to work. If you're going to use hours here, you're going to have to use hours here. Now you could translate this to seconds, but I don't feel like it. I'd rather do this. There are 3,600 seconds in an hour. There are 60 sets of 60 in an hour. So 1 second is 1/3600th of an hour, and this unit is not on the bottom of the fraction, it's on the top of the fraction effectively. So when you divide, you don't get per hour, it's still hours. This 1 divided by 3600 is 0.00278 hours, and the hours is not on the bottom of a fraction. It is just straight up hours. Then we can move it across the equal sign by doing the opposite of whatever is happening now. It's multiplied by A, so let's divide it across, and nothing's going to cancel out. Actually, the hours are going to multiply on the bottom. We're going to get kilometers per hour squared, which is correct. For an acceleration, we should get a distance per time squared. Here's the problem. That's not meters per second. Well, let's cancel it out. How many meters are in a kilometer? And I'm hoping by now we know that kilo means 1,000. There are 1,000 meters per kilometer. And if you took a chem class, and I know most of you did because I was there, we're supposed to know how to use a conversion factor. Flip it until it cancels out the thing you don't want. I don't want kilometers, I want meters. Okay, so let's put 1,000 meters on top. Put 1 kilometer on the bottom. The kilometers cancel out. and we're going to get this times 1,000. The real trick here, and I did this wrong myself, and I got an answer that I knew was pretty dumb, but I couldn't figure out why for a moment. We're trying to cancel out hours squared, and get seconds squared. So we have to put an hour squared up there. Well, 1 hour squared is whatever an hour is in seconds squared. Cover over the 2, and isn't that true? 1 hour is 3,600 seconds, right? So this squared is that squared. Now the hour squareds cancel out, and we're going to get this value squared. I didn't write it down. And 18,000 times 1,000 divided whatever that is, or another way you can do it, and you can test me on the calculator, but I am correct. I encourage you, go do it. 18,000 times 1,000 divided by 3,600 divided by 3,600, because that's what the squared down here means, and you get 1.39 meters per second squared.